Hello folks, we are back with another video. This is could be called as part 12 from the miscellaneous exercise. This is like they have given us one equation and they ask us to find dy by dx. That's okay. Here that's okay because always it's better that we get if they ask us to find out a dy by dx, that's if they give us a dy by dx, it's very easy for us in the exam. It gives us an idea as to what the derivative should be. So it's a blessing. It's good that you have they ask us what is you have to show that dy by dx is a particular thing that's given in the question. So we start with this as like we did the previous question, can be done in many ways. We'll choose one of the methods and we'll do it. Can be done very elaborately, but let's see how we can get across doing it. You have the question x root of 1 plus y root of 1 plus x equal to 0. Our idea is to find the dy by dx derivative. So it's an implicit function. Everything is mixed together, right? Generally, we have y on one side, x on one side. We take dy by dx to get the answer. But here it's not like that. It's implicit. So you could do it as usual by a product rule and then get the answer. That could be complicated. So we will try to organize and maybe slightly differently we'll try to do it. So let's see how we go about doing this. Let's call this as x root of 1 plus y. Take this on the other side, so it becomes minus y root of 1 plus x. Then let's have one side fully with x things and one side fully with y things. So let's see how it is. This will be x by root of 1 plus x. And on this side, you have minus y by root of 1 plus y. So you have x on one side, y on the other side. Now it's better. We can go in for the derivative, but still it's u by v, so maybe it's a quotient, so maybe it's slightly more difficult. Let's square it so that things becomes a little more easier. So let's have squaring. Let's square both sides. So when we square both sides, this will become x squared by 1 plus x. This will become y squared by 1 plus y. We have squared. Now let's organize. Let's get the terms that way. So you have x squared times 1 plus y and y squared times 1 plus x. So x squared plus x squared y squared plus y squared x. Still, it's not the right time for finding the dy by dx. Let's get more things organized. Let's have everything on one side. So you have x squared plus x squared y. We are bringing this on one side. Y squared minus y squared x. Let's group these two terms together, So what happens? You're getting x squared minus y squared plus x squared y minus y squared x. Why we are doing so much of steps is so that if we can make the expression as simple as possible, then finding the derivative will be easier. And we can do it. It's not that we cannot do it. In certain cases, it so happens that you try to do it, but you're not able to simplify it, then there's no way out. Then you go to find the derivative. But here it's not like that. We are able to simplify it. So let's simplify it. And then we'll find the derivative. So that finding the derivative is not a big task. So here what we're going to do now is we're going to factorize. We know that x squared minus y squared, we all know breaks up as x minus y into x plus y. So also this we know that there is an xy common. So let's take that out. Factor here, leftover term here is x, leftover term here is y. So we are having x minus y times x plus y plus xy times x minus y equal to 0. When we look at both these terms broadly, x minus y is a common factor there. So let's take the x minus y common. So we are taking the x minus y common. Then in that case, in the first case, the leftover term is x plus y. Here the leftover term is xy equal to 0. So the product is 0. When the product is 0, each term is 0, or like how the case is. So it could mean that either x minus y is 0 or x plus y plus xy is 0. Now x minus y, if it is 0, it means that x is y. If x is y and we try to put it into this expression and we try to simplify it with the domain that is given for x, we get specific values of x. We get x as 0, x as minus 1, something like that. I'm not going to the solving of it. If you require further clarification, you can comment, and on the comment I will reply back to you as to how you get it like that. So it is like when you further solve, when you take the value of x equal to y, substitute it in that equation and further solve, we are restricted to the value of x. X becomes 0 and minus 1. That is not allowed because x is in the entire, x is a value in the domain. It is it between minus 1 and 1 can be any value. It's a variable, so you cannot specify that it's only that value. So that is why we don't proceed with this. We stop this over here. This is not the correct alternative, and we move to this, and from here we try to find out what is the derivative. So x equal to y or this. Now let's consider this and let's move. So now consider x plus y plus xy equal to 0. You require dy by dx. Keep that in mind always. Let the x go on the other side, so it becomes minus x. Here you have amongst these two terms y common. Let's take it out. Y times 1 plus x. Why? Because we want y equal to something so that you get dy by dx. We are doing our work accordingly. So you're getting y equal to minus x by 1 plus x. That's it. Now we can go on to find the derivative. So you get dy by dx. So you can do it in two ways. One is that you can rearrange and then try to get the derivative, or directly by quotient rule, whatever way. Suppose if you are doing quotient rule, then it is 1 plus x. Derivative of minus x is minus 1 minus, you can have minus x, so that will make it plus x times derivative of 1 plus x. Derivative of 1 plus x is 1 itself. Why? Because derivative of 1 is 0 and derivative of x is 1. I'm not going into the details of it, but we all know that a quotient rule, by quotient rule, if you have u by v form, then the derivative is v into derivative of u minus u into derivative of v. That's what we have done. Denominator here, derivative of the numerator, minus into minus plus, numerator here, derivative of the denominator. That's how we've done it. And numerator, denominator by v squared. That's a formula. So when we further simplify, minus 1 minus x plus by 1 plus x the whole square. Plus x minus x cancels each other. We are left with minus 1 by 1 plus x the whole square. That's what they have asked us to show. So this is how it works. We could have done it right there by implicit function. It would have been a bit lengthy, and things are not so easy. So that is why what we do is we try to simplify and then we try to get the answer. That's all for this video. With the next question that's slightly complicated, we'll come further with the next video. Thank you.